Okay, so this demo, software-defined radio demo, I'm going to be using showing you how to use a restaurant pager and how to trigger that to ring or beep or buzz using a software-defined radio. In this case, we're going to be using the BLADERF. So I don't know if you're familiar with the restaurant pagers, but basically, if you go to a restaurant and there's a wait, the waitress will give you a pager so that once your table's ready, the pager will ring and indicate that your table's ready, and you bring the pager back, and then you go ahead and get seated. So that's what I'm going to show you how this works and how you can use SDR to actually generate a signal to make the pager go off, basically. Probably be help if you looked at my previous video on how to do the remote doorbell ringer. It's a little bit simpler. It's the same sort of theory behind it. It uses amplitude shift keying, but the bit pattern is pretty steady state, whereas for this one the bit pattern is a little more in depth, and the bit pattern changes depending on which pager you use. But it might be worth it just to look at the doorbell ringer I have out from before. So what we're going to show in this demo is how to capture a signal from a pager using a software-defined radio, and then we'll take that signal we capture and just play it right back. And for both those steps, 1 and 2, we'll be using GNU Radio Companion in conjunction with the BLADERF to receive and transmit the signal. And then we'll look at the signal we captured and maybe do a little bit of signal analysis of it just to see how it works and what the bit pattern looks like. And then once we determine that, what the bit pattern is, we'll go ahead and use Audacity to actually look at the bit pattern, and then we'll use SDR Companion to synthetically generate the signal. So we won't need a captured file to actually play back to get it. We'll actually have GNU Radio Companion generate the signal for us. So for the parts, I have this, it's a wireless calling system. There's the part number. There's the other number I got off. You can get it at Amazon. I think it's like 120 bucks. The FCC ID number is right here if you want to look it up. And then the frequency for this particular device is 433.92 megahertz. And it uses amplitude modulation to go ahead and do the encoding. And basically what the device looks like, it's a series of 10 pagers with a base station. And you press one of those little numbers there, 1 through 10, and it'll make the pager go off. So depending on which pager you want, you just press the number. In this case, in this demo, I'm going to be using, I think, pager 6 a lot, just to go ahead and transmit and receive on that. Just picked a number, decided to go with 6. That's what the pager looks like. That's what the inside looks like. There's not much to it. There's a little battery in the bottom you can see there. And if you look on the back of the base station, it actually tells you what the frequency is of this device. So it shows you, it says it's 433 megahertz, but it's actually 433.92 megahertz. And then for the SDR, we're going to be using the BLADERF new N radio. I really like it. It's good for transmitting and receiving signals. It does cost a little bit. I want to say it's around 400 bucks maybe. I don't know, but it's got really good coverage. And I use it a lot just to play around with the signals environment. Now on the Windows side, I have the GQRX SDR. What that lets me do is just look at the signal environment really quickly to see, does it really transmit on this frequency? I think it does, and just kind of look at it and see if I'm picking it up, and just do a quick sanity check to make sure that everything's where it's supposed to be as far as frequency-wise. And after I do that, then I'll use GNU Radio Companion to actually capture the signal and then play it back. And then I'll use another software package called Audacity to actually do some signals analysis of the bit pattern I captured to figure out how this thing works. All these things are free, so it doesn't cost you anything. And if you want to hear how it works, let's see. So you can see there's not much to it. I just press the number 6 and then the pager goes off. And we'll be using our SDR to actually do that, pretend to push the button sort of thing. If you want to look up on the FCC, you can certainly put in the FCC ID number and do a search, and something that looks like this. It'll show you a bunch of letters, cover letters, and the thing I usually look at is the test report. And sometimes the test report has a lot of good information in it as far as how the device works. In this particular instance, it has a little picture in there. It tells you what frequency this thing transmits on, 433.92 megahertz. Better test reports will tell you what the actual bit pattern looks like. Like here's one for something I've looked at before where it actually shows you the bit pattern. But this one doesn't do that for you. I didn't see the bit pattern in the test report. But it doesn't really matter because we're going to be using Audacity to actually give us a similar looking signal so we can determine the ones and zeros. So for the setup, we have our base station and our pager number 6, and we're going to be doing this setup just to capture the signal. So we're going to be using our SDR to actually capture the transmitted signal from the base station. And the SDR is plugged into our Windows computer, and then from the Windows computer we're running a GNU Radio Companion, and it'll go ahead and save that data off to the hard drive. So I press the button number 6, it will go ahead, base station will go ahead and transmit to the pager, and we'll also transmit, I'll pick it up with my SDR. The SDR will save it to the computer as 2 files, channel6.wave and channel6.dat. I like both formats. The DAT file is the one you actually play back in the replay of the I hate to say the word attack, but it's just when you do the replay of the pager, you want to use the DAT file. I use the WAV file because it's a little easier to visually look at the ones and zeros on Audacity, and I'll show you how that works a little bit later. And then of course the pager will go ahead and ring once I press the button. And for replay, it's a little bit simpler, where I'm going to have my SDR. It's going to be plugged into my computer again. I'm going to have my pager, again, channel number 6. And I'm going to have my channel6.dat file going into my GNU Radio Companion. And then the SDR will go ahead and transmit that signal, the channel6.dat signal, to the pager. And then that will cause the pager to go ahead and ring and vibrate. This is all being done through the SDR now. I don't need the pager base station anymore. So let's go ahead and show you a quick video demo of how this actually works. I'll show you how I'll use this various free software I talked about to actually receive the signal, look at it, save it off, and then we'll go ahead and replay the signal and make the pager go. Okay, so let's go ahead and go to my website. Go to the Silver Cloud Computing website up in the browser. And once you get here, I'm going to go ahead and go to the SDR part of the web page. So click on that, and if you scroll down toward the bottom, you'll see the pager stuff I put together. It's just past the doorbell stuff. So if you go ahead and click and download some of these files here, we'll download. And you have to save it as a file name because it gives you a funky name. So just save it as like channel 6 receive GRC to your downloads directory. We'll go ahead and save that. And then go ahead and do the transmit. This is going to be for pager channel 6 again, so we'll just do the transmit pager channel 6. And then we'll go ahead, after we save that, there we go, we'll go ahead and save the synthesized version. This will be the version that we'll use to have GNU Radio transmit the signal for us. Let's go ahead and save those. Go ahead and save that. And let's go ahead and close the browser out. And what I'm going to bring up next is the GQRX thing. So we're going to bring that up now. What we're going to do is we're going to bring it up and we're going to transmit our signal just to verify that it's actually on 433 megahertz. So let's go ahead and start that up. Then I'm going to go ahead and hit the pager button and we'll see that it'll show up on here. Okay, so I did that 3 times, and I'm going to go ahead and verify, yeah, that was actually 433.92 megahertz. So let's go ahead now and bring up GNU Radio and use the the templates that we got. Let's go ahead and do that. So we'll go ahead and we'll do the receive one first. So this is a template that lets you, it'll go ahead and receive the pager data and save it to file on 433 megahertz. So there's the template that I got. This works for me. It works on my desktop. And on the left is the actual receiver. So that plugs into GNU Radio, plugs into the SDR radio. And then from there, I can go ahead and save the DAT file. And that's when we'll do the playback. And then I can actually go ahead then and then save the WAV file, which is what I use to like I said, it breaks up the bit patterns a little better, so I save that. So let's go ahead and try that. So I'm going to go ahead and hit start. And let's see. And there it goes. All right, let me do it. So I did that 3 times. Let me turn it off again. So that's saved. So again, I just saved 2 files. Now we're going to bring up the transmit part. And all that does is it just references the DAT file we just grabbed. And now we're going to have the GNU Radio companion play it back for us. And it should make the pager go off. Go ahead and hit play. Give it a second. There it goes. Okay, it's not showing up on the thing yet. There it is. Yeah. There's a little bit of a lag time between the display and the actual pager thing going off. So there's the 3 of them. Okay, so that's receive and transmit. So for, building on what we just did, doing a little bit of signals analysis using Audacity. Again, we captured 2 files, the channel 6.dat file, and if you bring up Audacity, it's going to look something like that. A bunch of fat pulses and skinny pulses. And we also captured it in a format called channel 6.wave. It's just a WAV file. And I like using the WAV file because you can see here it looks a little bit cleaner as far as seeing the pulses. They're very clean. You can make out the 1s and the 0s. And if you actually count up all those pulses, you see that for this particular pager, it's about 26 bits. So if we want to bring up Audacity and do a little signal analysis, bring up the DAT file. Again, it'll look like this. And if we say the fat pulses are 1s and the skinny pulses are 0s, we'll go ahead and get a bit pattern that looks something like this. Now for this instance, I highlighted in red what the critical bits are as far as determining what channel we're transmitting on. I'll go into that a little more detail a little bit later, but basically there's 4 bits there identify which channel we're on, whether it's channel 1 through 10. Now if we're actually to measure the signal, if we look at the 0s and the 1s, the 0 is going to be, the whole pulse is about 1,300 samples wide. And the 0 is going to be 325 samples, and the 1 is going to be 975 samples. Now those numbers aren't random. If you do a little bit of math, you can see those numbers actually, kind of make sense a little bit. So let's go ahead and talk about that. So if we say our pulse width is, like I said, 1,300 samples, and our 0 is 325 samples, well, that's actually 1/4 of a pulse width. And if we look at our 1 is 975 samples, that's 3/4 of a pulse width. So what this tells me is when I set up my GNU Radio companion to actually synthesize the signal, I'm going to need 4 inputs to actually recreate this signal through the computer. So let's take a look at some different patterns. So like I said, the 6 looks like this. Again, you got the 26 bits, and you got the 0110 to signify that it's a 6. If I were to transmit a 7, it would look like this. And again, the 4 bits that signify a 7 would be right here. And if you read it from right to left, so you go 0, 1, 1, 0, 0, 1, 1, 1, that's actually a binary 7. And we can do the same thing for 8, 1, 0, 0, 0. And then we can do the same thing for 9, 1, 0, 0, 1. And again, there's 10 pages, so you can do this through 1 through 10. So let's go ahead and do the video demo of this, looking at the signal and then having GNU Radio actually transmit it for us. So we'll use Audacity to actually look at the signal, and then we'll use GNU Radio to actually transmit the signal. So we won't have to rely on that DAT file anymore. All right, now I have Audacity, and I'm going to go ahead and bring that up, and then bring up our DAT file and our WAV file. So at the top, I think you can see there's the WAV file. So it looks, you can see how easy it is to break out the 1s and the 0s are pretty easily defined. That's why I like using it, because it can really see easily. And if we take a look at some of the pulses and what they look like, you can see what the 0s and 1s are. Let's go ahead and see if we can measure some stuff here. So I'm going to go ahead and import the DAT file, channel6.dat file. And again, this is the actual file we received and the one we transmit in that previous demo. So you can see there's a couple pulses there. Actually transmits quite a few of the same pulses in each burst. So I don't know, do 20 or 30 times. So let's go ahead and zoom in on one of those. And again, you can see the fat ones and the skinny ones. That's pretty easy to determine what the 1s and the 0s are. We can kind of just see there's about 26 of those there, 26 pulses that constitute the whole signal. And if we zoom in and just go ahead and measure some of these, so we see there's about 1,300 samples for each of those pulses. And if you look at the other one, at the 1s, the fat pulses, again it's 1,300. And then we can measure the actual size of each pulse. So the 1 I think was 375. I mean the 0 was 375, and the 1 was I think 975. So we'll measure the other one. I think it's about 975. So that's how we can actually do the measurements in Audacity to figure out what's what, how it works. And then we can use that information to plug in how to have the computer actually generate those signals for us instead of relying on something that was captured. So if you bring up the synthesized version I put together, let's go ahead and open that up. And this doesn't rely on any DAT files. The computer actually generates it for you. GNU Radio Companions. I know it's a little complex, but you see there's 4 inputs, like I said. 1, 2, 3, 4. And on the far left is the bit pattern that goes into those 4 inputs, and that determines the bit pattern that gets outputted. And if you scroll down to the bottom, you'll see there's the transmitter. And I actually save the DAT file in this one just so I can look at it, and the WAV file so I can look at it just to see how closely it looks to the original. Again, you just have to get in there and play with it and take a look at it. And if you look in the upper right, let's see, so there's the bit pattern. Right there I have a variable in there that determines the channel number. And that variable is referenced up above. Let's see. That's where you'd actually put in the bit pattern for the channel number. So you click on that. I think right now it's channel 6, so 0110. But if you want to put another value in there, like 1110 or something like that, that would be channel 7, and they're all laid out right there. So that's where you would put the variable for the channel. So let's go ahead and start that, and we'll see if we can get something to beep here. Now, because it's transmitting all the time, I'll stop the pager. It's going to keep going off all the time. So I have this just going in an infinite loop for transmitting. Okay, I'll stop that. So, okay, so that's the synthesized version. Very cool. Okay, so that's it. It's pretty simple. We used what we did in this video is we captured this wireless restaurant pager signal with a software-defined radio. We captured the DAT file, and then using the GNU radio and the SDR, we played back that captured DAT file to make the pager go off. And then we used Audacity to just look at the bit pattern to figure out there's 26 bits in this particular device, and which 4 bits identify which actual pager channel it is, 1 through 10. And then we used GNU Radio Companion to have the SDR transmit the bit pattern. So like I said, the best way to learn this stuff is just download the GNU Radio templates I have. They work for me, and just kind of poke around, see how it works, look at the synthesized version, see how it works, and kind of try and follow it around. It kind of makes a little sense once you dig into it, and just play around with it. That's really how I learned all this stuff. And again, if you have any questions, just visit the website. You don't have to go to the NiFi part. That's just part of the standard template I got. But again, my email, you can do NiFi. I'm big into NiFi. That's my big thing. You can just do mike@silvercloudcomputing.com. But if you have any other ideas as far as any other devices you think I'd like to look at, I know I was looking at a power strip. I have a remote control power strip I was playing with. That was kind of cool. But once you figure one out, you can kind of figure them all out. But if there's any other devices or any other things out there you might think worth interesting, just drop me an email and I'll see what I can do. All right, thanks for watching.